Welcome to day 8 of my AVR Advent Calendar. In this series of videos I will show you in 24 days how to program the AVR 8-bit microcontroller. So today I don't have a bag here because the bag will be empty, because today we will talk about interrupt pins and how to use them with AVR 8-bit microcontrollers. But first let's take a look at the pinout. So here is the pinout of our Atmega 88 microcontroller. And you can see here we have two interrupt pins, interrupt 0 and interrupt 1. And today I want to use these interrupt pins. So whenever I press this button here, an interrupt will be triggered and the interrupt will increment the value which is displayed here on the 7-segment display. Okay. So what we have to do here is, so I will use interrupt 0, so I have to set port D pin 2 to an input, and I will enable an internal pull-up resistor. And now let's take a look at the Atmega 88's datasheet to see which registers we can use for controlling the interrupts. So the first important register is the external interrupt control register. So we have two interrupt pins. The first two bits here are for interrupt 0, the second two are for interrupt 1. And here we can set on which event an interrupt should be triggered. So we have the option if we set both bits here to 0. If we have a low level, an interrupt will be generated. If it's set to 1, any logical change will generate an interrupt. If we have a 2 here, the falling edge will generate an interrupt. And if we have a 3 here, the rising edge will generate an interrupt. As I'm using an internal pull-up resistor, I want to have the falling edge to generate an interrupt. So I will set these two bits here to 1. Okay, what else does we have here? So we have the external interrupt mask register, and here we can enable the interrupts. So here I have to write a 1 to this bit to enable interrupt 0. And the last register here is just for information. So this is the external interrupt flag register. So in case an interrupt occurs, this bit here will be set. And if we want to acknowledge the interrupt, we would have to clear it, but this will be also done if we call an interrupt service routine, which I will do. Okay, so the first thing I need is I have to change the wiring a little bit. Last time I used pin 7 here, and now I have to connect it to pin D2 here. So let me change this live here. Okay, this was the wiring change. Now let me cd into my AVR Advanced Calendars folder, and I will copy the source code from our 7-segment display, and I will create a new folder, pin or ext interrupt. Okay, let me cd into this folder. What do we have here? We have a main file with the source code and a makefile to build our program. Let me open up the main file. Okay, and here we have a program. So we are having these 7 outputs for the 7-segment display. Here we are initializing an input pin, and here we are waiting if the pin is pressed, and if so we are incrementing the counter variable, and else we just output the we set the value of this pin here. Okay, and now for using interrupts, I need to include AVR/interrupt.h. Then I will change the button here to pin 2. So here I will set port D pin 2 to input here. Okay, and now I have to I write to the interrupt control register a 2. So this means ERQ trigger falling edge. Then I will enable the interrupt. Or enable interrupt 0 at least. And now I will use as they to globally enable the interrupt. Enable ERQs. Okay, but now what will happen when an interrupt occurs? Well, if so, I have to call an interrupt service routine. So let's add our interrupt service routine up here, And here as an argument we have to pass the interrupt, the source for our interrupt, and here we are using interrupt 0 here. This counter variable I will declare as a global variable. Okay, and if an interrupt occurs, first I will disable global interrupts. Okay, and then I will just, let's add a little debounce here. So let me copy this delay here for debouncing. I don't know if this works, but let's try. And then at the end I will enable the interrupts again. Or let me copy this from down here. Yeah. So this is all I have to do here in the interrupt service routine. And down here, I don't even need the state variable any longer. And I can delete this. So all we're doing in the main function is we're updating the display in an endless loop. That's all. And if we press the button, we will jump into this interrupt service routine and we will increment the counter variable, and that's it. Okay, cool. So now let me try to compile this program. So I will run make. Compiling worked successfully, and now let's flash the program. So let's flash it to the microcontroller here. I have to give it my password. Okay, and now if I press the button here, okay, it's a little bit, I will take this pen here to press the button. Okay, you can see it's working, but the debouncing isn't working so great. So we have a small bounce problem here, but never mind, the interrupt is working. Okay, so that's how to use an external interrupt in an AVR 8-bit microcontroller. I hope you've enjoyed the video and learned something. Thanks for watching, and I hope I will see you tomorrow. Bye!